Okay, everybody, hello. This is Thursday, November 12th. This would originally have been the lesson that we would have done on Monday, November 16th, but because of the storm, we're switching it up a little bit. So today we're actually going to start Unit 7, and this is going to be covalent bonds and molecules, okay? So just give me a moment to get everything set up. So this is going to be the covalent bond. Okay, now let's do a review of what you've been taught so far. We learned about ionic bonds in the last unit. Ionic bonds are a force formed between a cation, which is a positively charged ion, and an anion, which is a negatively charged ion. A force formed between a cation and an anion due to electrostatic attraction. So basically, positive attracts negative, and they're able to come together to form an ionic bond. So for instance, a sodium ion reacts with a chloride ion to yield sodium chloride. The compound is neutral. It has no charge, but it is made up of a cation, and it is made up of an anion. Okay? Now, this is called an ionic compound. And both in ionic compound and ionic bond, you hear the word ion and you hear ion. Now, a lot of times, an ionic bond is going to have a metal and a nonmetal, but you also have those polyatomic ions. Hopefully you remember the 8 that I told you that you had to memorize. You have hydroxide, phosphate, sulfate, acetate, let's see, nitrate, nitrite, let's see, 1, 2, 3, 4, 5, 6, we got 2 more, carbonate, and ammonium. Those could also be the ions that would be involved in these compounds. So I want to be very clear about something that you're about to hear. I can't be any more clear than how crystal clear I'm going to be. There are no ions in covalent bonding. Got it? No ions whatsoever. No charges at all. Nada, nothing, zip. Now, the purpose of these ionic bonds in these ionic compounds is so that it allows each ion to achieve stability. A classic example with the sodium ion, for example, or this is a sodium atom. You have your nucleus. You got 2 electrons in the first energy level. 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second energy level, and 1 electron in the third energy level, because sodium has 11 protons and 11 electrons. Chlorine has 17 protons and 17 electrons. So it's going to look like this. This is all review. 2 electrons in the first energy level, 1, 2, 3, 4, 5, 6, 7, 8 on the second energy level, and then 1, 2, 3, 4, 5, 6, 7 on the third energy level. Hold on one second. My dog is getting into trouble. Come here. Yay. All right. I'm back. Okay. Now, neither of them are achieving an octet. An octet is when you have 8 valence electrons in the outer energy level to make you stable. Sodium has 1 valence, chlorine has 8. So here's what we're going to do. We're going to take this 1 valence electron from sodium, we're going to move it over here, and that is going to make both sodium and chloride stable. But because of that change, sodium loses an electron, so now it has 10 electrons, and chlorine gains an electron, so now it has 18. Because chlorine has one more electron than protons, it will have a -1 charge, and its name changes from chlorine to chloride. Sodium goes from having an equal amount of protons to electrons to one more proton than electrons, so it will have a positive charge, and it will just be called a sodium ion. Because these two are now charged, they're going to attract each other. And because sodium is +1 and chloride is -1, they're going to equal each other out at a 1-to-1 ratio. The whole purpose is to achieve stability. But there's more than one way to achieve stability. And that is what we're going to get into today. We're going to talk about molecules and covalent bonds. So I want to start off by a little rhyme. It says, sharing is caring. And caring is covalent. The reason I say that is because this is how covalent bonds are different than ionic bonds. What you saw above here, the anion, or the more electronegative element, chlorine in this case, stole an electron from sodium. That's stealing. Covalent bonds share. They share electrons. You share a home with your siblings or with your parents or your pets. You all share the same structure, the same house. You guys share a classroom with about 25 other students in my room. You're sharing it and you're all getting use out of it. Well, in covalent bonds, they are being shared. So you still have the common purpose, which is to achieve stability via an octet. You're trying to still get 8 valence electrons, but we're not going to be stealing and sharing. We're going to be, we're not going to be stealing, we're going to be sharing. So typically in an ionic compound, and I'm only mentioning ionic compounds for the sake of comparison, you typically have a metal, which would be positively charged, and a non-metal, which would be negatively charged. In covalent compounds, which we call molecules, you're going to be hearing me make this change to your vocab. Covalent compounds are called molecules. One second, let me close my window. There's a hurricane out there, and there's a lot of construction trying to get all the tree branches and all the damage that's been going on outside. Covalent compounds, which are called molecules, are basically 2 or more non-metals. So you're going to be basically dealing with the right side of the periodic table, the P block, and hydrogen from over in the S block. Okay? Now, here's a term here, molecule, as I just said. A molecule is formed by the bonding, by the covalent bonding of 2 or more non-metals. Remember that in these bonds, electrons are shared, not stolen. And to be more specific, it's the valence electrons only. I want to make sure I'm clear on that. Valence electrons are the ones that dictate bonding ability. All right, so let me give you an example here, kind of a crash course, if you will. Here's a very simple molecule that you have learned before. This is water. This is a water molecule. I say it is a molecule because it is made up of hydrogen and oxygen. Hydrogen and oxygen are both nonmetals. If you look at the periodic tables that you colored in, you'll see that they are both nonmetals. Now, let's draw the electron dot structures for each of these. When you see H2, You know that this molecule has 2 hydrogens. So let's draw the dot structure of 2 hydrogens. How many valence electrons does 1 hydrogen have? The answer is 1. So there's 1 valence there, and there's the other valence there. So there's our 2 hydrogens. And then we have oxygen. How many valence electrons does oxygen have? Well, you should look at it on the periodic table. It is found in group 16. So that means it has 6 valence electrons. 1, 2, 3, 4, 5, 6. Hydrogen is unstable because it only has 1 valence electron. Oxygen is unstable because it has 6 valence electrons. Hydrogen needs 2 to be stable, and oxygen needs 8 to be stable. So what we're going to do is we're going to move things around a little bit. Check this out. I'm going to move this electron right here. If you like doing puzzles, you're going to really enjoy this unit. I'm going to move that there, and I'm going to plug it in. Whoops. Let's move it right there. And then we're going to take this hydrogen, we're going to plug it in right there. Okay, and let's draw some circles here. Right now, how many valence electrons does that hydrogen have? It has 2. And now it's 2 valence, it is stable. How about this hydrogen? It has 2 valence, it is stable. Remember, hydrogen and helium only need 2 to be stable. And then we have oxygen. How many valence does it have? It has 8 valence. It is stable. So at a ratio of 2 hydrogens to 1 oxygen, these 3 atoms have stabilized each other. And they now all have a complete valence shell. So if I were to draw, I like to call this drawing that you're looking at right now my rough draft of my final molecule. Now let's do our final draft. You're going to have oxygen here, hydrogen and hydrogen, and then we draw the 2 unpaired electrons. These guys right here, or these, up above. You always have to draw the electrons that were not involved in bonding. We call this an unshared pair. Okay, that's basically how covalent bonds work. And so this is a covalent bond, and that is a covalent bond. And when you see a covalent bond like that, that line that you're seeing right here and right here, this represents 2 electrons. One electron from the hydrogen, 1 electron from the oxygen. So what you're looking at are 2 single covalent bonds. I say single covalent bond because it's just 2 electrons, 1 electron from the oxygen, 1 electron from the hydrogen, and that's, by definition, is what a single bond would be. And you're going to learn about double bonds and triple bonds later, okay? All right, well, first off, next I want to get to something called diatomic molecules. Now, a diatomic, you see the word di. What does di mean? How many? It means 2. 2 atoms, 2 atomic. So diatomic molecules. So what you're going to be dealing with here is that there are 7 non-metals that cannot exist by themselves. The reason why is because their valence levels are unstable. They don't have enough valence electrons to be stable. So, what they do, here's the solution in order to achieve stability. They bond with another atom of the same element to be stable. And these are called the diatomic molecules. And there are 7 of them. You have hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. The way that you're taught this in class is have no fear of ice cold beer. Have no fear of ice cold beer. Now I want to just say, in my experience of teaching this class, I want to remind you guys of a couple things. The C in have no fear of ice cold beer is chlorine, not carbon. And the beer, the B, is bromine, not boron. I've had people make that mistake a lot. So I'm going to show you how each of these is made, just so you can see how it's done. And then I'm going to talk about how a covalent bond is actually formed. And then that will really be it for today. Okay, so let's go over these. Let's do hydrogen first. I'm going to go through all 7. We know that hydrogen is unstable. It has 1 valence electron. It needs 2. Okay. So you're just going to get another hydrogen ion. Like I said, they bond with another atom of the same element to be stable. So just get another hydrogen. So now we have 2. So move the electron around a little bit. You're allowed to do that. And let's bring this one over here. So how many valence electrons does that black hydrogen have? 2. How many does that red one have? That's also 2. So we would write it like this. That is called H2. This is a hydrogen molecule. A hydrogen molecule is 2 hydrogen atoms bonded together covalently, and they complete each other. This is a single covalent bond. What you see right here, that is a single bond, a single covalent bond. 1 electron from the hydrogen on the left, 1 electron from the hydrogen on the right. Now, because you guys are new to chemistry, I could definitely say you'd be confused. There's actually 3 different ways you look at hydrogen. I want to be sure that you all are aware of this. This is a hydrogen atom. This is a hydrogen ion. And this is a hydrogen molecule. A hydrogen atom has 1 proton, 1 electron. An ion has 1 proton, 0 electrons. And the molecule is 2 hydrogen atoms bonded together covalently. Okay, so that's the hydrogen. Let's go on to nitrogen. I'm going to teach you more about this one tomorrow, but I'm just going to get you exposed to it. Nitrogen has 1, 2, 3, 4, 5 valence electrons. Now, how did I know that? Well, you should be able to know that too. You look at the periodic table and you find out that hydrogen is found in group 15. That means it has 5 valence. All you have to do is use your eyes and look. Well, it is clearly unstable. It's not going to have a stable valence shell, so you're just going to add another hydrogen to this. Or did I say hydrogen? I meant nitrogen. So you're going to have 2 of the same kind. So we're going to shuffle things around a little bit. So here's my black nitrogen. I'm going to put 2 electrons here and 1, 2, 3 there. Here's my green nitrogen. I'm going to put 2 electrons here and 1, 2, 3 there. How many electrons are in the green one? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. How about the black nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. There's 8. This is called a triple covalent bond. So to write it really nicely, it's going to look like this. These are called triple covalent bonds. That's the hardest one to really understand. I'm going to teach you that more tomorrow. And this forms N2, which is a nitrogen molecule. This is what actually makes up the majority of Earth's atmosphere, nitrogen gas. At room temperature, this would be a gas. Same thing with hydrogen, it would be a gas. All right, so we have no fear. Here's the next one, fluorine. Hold on one second. Somebody just contacted me. Give me 1 second, guys. I spelled it wrong while I'm thinking of it. I told you not to spell that way, and here I am spelling it wrong. Silly me. U before O. All right, so fluorine. Fluorine is found in group 17. It's a halogen, so it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. It is found in group 17, which means it has 7 valence electrons. It is unstable. It needs 1 more. So let's give it 1 more. And let's draw another fluorine. 1, 2, 3, 4, 5, 6, 7. There you go. Okay, so those of you who like puzzles, I'm going to give you a minute to see if you can figure out how will it go together. If you don't like puzzles, you're going to have to get good at it. So I'm going to just be quiet for a moment, pause the video, and try to figure out how it's going to go together. Got it? Here's how it's going to look. How many electrons does the blue fluorine have? 7. How about the black fluorine? 7. What type of bond is this? This is a single covalent bond. Notice how I am drawing all the unpaired electrons or unshared electrons. And this is a single covalent bond. All right, have no fear of. Next one's going to be oxygen. Oxygen is found in group 16. So it has 6 valence electrons. 1, 2, 3, 4, 5, 6. That's just not going to cut it. It is unstable. It needs 2 more. So let's give it 1 more. 1, 2, 3, 4, 5, 6. I'm going to pause the video and see if you can figure out how they're going to connect with each other, how they're going to bond with each other so that each one gets 8 electrons. You have to check your math. So pause the video and see if you can get the 2 of them to bond together evenly so that each of them, the gray one and the black one, has 8 valence electrons and no more. Okay, if you paused it and you figured it out, let's see what you got. Here's how it's going to look. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many valence electrons does the black oxygen have? 8. How about the gray one? 8. What type of bond is that? It's obviously covalent, but how many? It is a double covalent bond. 2 pairs of electrons are being shared. This is known as a double covalent bond. And this would be O2. Remember that this is an oxygen atom. This is an oxygen ion. That's oxide. And this is an oxygen molecule. An atom has 8 protons, 8 electrons. The ion has 8 protons, 10 electrons. And the oxygen is 2 oxygen atoms covalently bonded together. Okay, to speed things up for the final 3, I'm going to tell you that, ice cold beer, that's going to be, those are all halogens, iodine, chlorine, and bromine. They're going to be just like fluorine. So let's just get them all down now. So we have iodine, bromine, and chlorine. Let's get them all just written down. One, 2, 3, 4, 5, 6, 7. Bromine, 1, 2, 3, 4, 5, 6, 7. And chlorine, 1, 2, 3, 4, 5, 6, 7. They're just like fluorine. They're halogens, so they're going to bond very similarly. Okay, here we go. All right. Here we have an iodine molecule. It's a single covalent bond. There's a bromine molecule. There's a chlorine molecule. I2, Br2, Cl2. The 2 means that there are 2 bonded together. So this is the have no fear of ice cold beer. Okay. That will be it for today. Tomorrow we're going to go more into single bonds, double bonds, and triple bonds. If you have any questions about any of this material, be sure that you send me a text or a Canvas message, and I'll respond to it as quickly as I can, okay? I'll share the next lesson tomorrow. Bye-bye.